2, 1. Introduction to probability. So in this video, I'm going to go over a few things, just kind of introductory items, which you typically will run into when you are starting off probability. Most of us kind of know what probability is, so you see here, I wrote in pink, how likely is an event to basically happen. We do like to have quite a lot of certainty in life. Unfortunately, it's very rare that we will have something which is 100% certain to happen. Most of the time it's going to be, ranging either from 0%, which is we have no idea if it will happen or not, or it won't happen at all, to, some particular range which gets, closer and closer to 1 or to 100%. Now, when you're studying in probability, you will be introduced to a few terms. Most of these terms, because you study probability a little bit later, my assumption is probably at some point in high school, maybe even in post-secondary, you will know these terms rather quickly if someone shows you some kind of a simple example and then points out what these mean. So for instance, if you're going to be conducting a probability experiment, which is consisting of just repeating trials of something. So let's say you have, I don't know, 2 dice, and then you're going to be throwing them, one after another, okay? And then you just keep repeating, okay? So you keep repeating, so you're creating these trials. And then you see and you record, okay, so what actually happens. Within that experiment, we call each single individual trial that you have, it's going to have some outcome that's going to be based on something that we're interested in. If you collect a certain amount of outcomes together and they have, let's say, as you're rolling, maybe you have rolled 2 dice and then you want to see when they add up to, let's say, less than 4 or something like that. So that could be an event. And then from all the different possible outcomes that we have, we create a sample space where it just encapsulates every single thing possible, okay, within our little experiment that we're conducting. So I'll talk about that in just a moment, and I will do it through an example. And then I'm going to come back and then talk about some brief items with regards to probability of an event, how we designate it. So as you can see there, it's probability, and then kind of in brackets where A represents whatever event that you're interested in. It doesn't have to be A. You can call it whatever you like. Most of the time we capitalize it. And then for probabilities, we should kind of know that probabilities range between 0 and 1 or between 0 and 100%, and that we can express probabilities in decimal, fraction, percent, to be honest with you, in any number representation, but they do fall in between that 0 and 1 range. If you calculate something and it has a negative probability or a probability of over 100, it's meaningless. It doesn't have any meaning to us, so something has gone wrong either in your computation or in the way that that experiment was set up. Now, lastly, okay, at least for this video, okay, so I'll talk about 3 basic types of probability. So that's empirical. So that's just done through experiments. Theoretical, I put a little star there because most of the time, in high school and post-secondary, you're not going to be doing a huge amount of experiments or empirical probabilities. You most of the time are going to be focusing on theoretical, right? So you kind of lay out what all the possibilities are. You don't need an experiment, and then you can calculate those probabilities. And then the last one is subjective probability, which is really just an educated guess. You can look outside and you can make a guess, all right, within the next hour, I predict that there's going to be no rain because maybe it's a beautiful day or something like that. But you can also do other subjective probabilities, which we do quite a lot of the time, right, as we go through. So let's take a look at this kind of one by one. So I'm going to, take this first, and then let's try to break it down, okay, in terms of some kind of an experiment. Now, it doesn't matter what experiment you choose, okay? So, as I said, so maybe we have, 2 dice, okay? So here is, 1. Let's make it a little, square, and then here's another one, and then we start rolling these along, okay? And as we roll it, maybe we will get a 1 and a 2. All right. Now, once you create that first roll of the 2 dice, you're basically creating a trial for this particular experiment, right? So that's what you would have. And then you can record what the outcome will be. Now, it depends what you're interested in. Maybe you're interested in the sum between the 2 die, or you just want to be able to see, what the result of each die is. So as I said, so maybe it was a 1, and a 2. So this is kind of maybe looking from above. Okay, so as you rolled in, maybe you got a 1 and a 2 right there, and then that would be your first trial. And you can repeat these trials, and obviously the more trials you have, the better that experiment becomes. Okay, if there's not a lot of trials, then the probabilities and the results that you have, you might not even get all the possible outcomes, right? If you only do, let's say, 3 trials of rolling 2 dice, then it's not going to give you all the possible outcomes, because as you know, a die which has 6 sides is going to have 6 different results. So, and then the other one, also has 6 different results. So throwing them along, will give you different types of results. So you have to have quite a lot of trials to be able to hit all the possible outcomes, that you have. Now, if by magic, you start doing all your trials and you do see, so I'm going to actually write these down for us. So let's say, I wanted to create kind of all the possible outcomes with here. So now this is more on the theoretical side. So I'm going to say, okay, we rolled our first die. So 1, 2, 3, 4, 5, or 6. Okay, so this would be, die number 1. And then on the top, maybe what I'll do is I'll write, 1, 2, 3, 4, 5, 6. Okay, this is the result of the second die. All right. And now as we do this, of course, we can, can create a nice little table for ourselves. And then I can fill these in. So, I could have rolled, so this is going to be my first, die. So could have rolled a 1 and a 1, right? It could have been from the first trial. I could have possibly, rolled a 1 and a 2, or a 1 and a 3, a 1 and a 4, or maybe, a 1 and a 5. Notice I'm running out of space here. 1 and a 6. So I'm going to kind of correct these out so that it is more centered, at least a bit. 1, 2, 3, 4, 5, and 6. Right there. And now I can fill this entire thing out. I'm going to do it in fast forward fashion, to save you a little bit of time. All right, so welcome back. So I just filled this out with basically all the possible outcomes that we would have if we would be conducting this particular probability experiment. Now, writing this out, so this is just theoretical, right? I mean, you're not going to be that lucky that you're going to be just kind of rolling, them off, or at least the probability is that you won't be that lucky. That you're gonna, do all of these different rolls, which would have been 36 of them, and then you would have been able to see kind of what happens as the result, right? Now, these are just outcomes that are possible. Now, when we do say an outcome, maybe we're interested in, so as I filled this particular table out, what is the result from the first die, and then what is the result from the second die, and I wrote it kind of in almost like a Cartesian, XY coordinate system, where the first die would have been your, your X input, and then your second input is your second die that you would be rolling. But maybe the outcomes that you were interested in was what the sum was, right? So you weren't actually interested in to see what the results were, but what the sum actually was. If that was the interest in terms of the outcomes, that would have changed our table, because we wouldn't put 1, 1, right? We would have just put 2, because the sum between 1 and a 1 would have been a 2. And then a sum between a 1 and a 2 would have been just 3. And then we would have had 4, and we would have had 5, 6, 7 in that first column. So maybe that's the outcome that you're interested in. And then you can fill in the rest of those, okay, as you like. So there are many different types of outcomes depending on what you're interested in seeing. Maybe it wasn't a sum, maybe it was multiplication between the two, right? So if you rolled a 3 and a 4, multiplication between those is 12. So that would have been the outcome, okay? So, I could have easily changed this, and I could have said, okay, well, my outcomes, I'm interested in actually the sum of these. So I would remove everything I've just done and then just replace it, okay, with the sums, which I'm magically gonna do that in just a second. All right, so magically, here you go. So those are the sums. And now these become your new outcomes. Now, what distinguishes between an outcome and an event? Well, an event, okay, so for instance, I can say here that, event A maybe is defined as, okay, so this is all the possible outcomes that might abide to the following, where the sum, all right, is, less than or equal to 4. So as you can see, there are many outcomes that are going to satisfy, okay, this particular constraint, which becomes the event that I'm looking for. And I would have been able to, highlight this out. So where's the sum less than or equal to 4? Well, that happens here, 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 and then it happens on all of these, right? And then everything else doesn't satisfy this particular event. So within here, okay, so this is my actual event that I have. Now, all the other outcomes, we sometimes write this out as kind of A bar or not A. So this would have been defined as, okay, this is where the sum is actually greater than 4. So sum, for instance, greater than 4 would have been known as, okay, so this is sometimes known as the complement. All right, and you may also write it as A prime. You might see that in textbooks as well. And the A complement, okay, so from this particular result, so that would have been everything else. And if you take the union of these two, so if you had A, in union with the complement of A, well, then that would have given you the entire sample space that you would have. So this whole thing becomes your entire sample space. And the sample space we typically will designate with a capital S. Those are all the possible outcomes that you can have, okay, in the experiment or the probability experiment that you're going to be conducting or, theoretically conducting. So for all of this, so this would have been, okay, defined as, okay, the union between the event and then its complement. So I think you can see, okay, how to go about and thinking about, okay, what are these trials? Well, those trials are actually if you're conducting and doing the experiment. What are the outcomes? Well, the outcomes, okay, are every single time you get a trial, you might get an outcome that you're interested in. Maybe it's the result on the 2 die, maybe it's the sum of the die, maybe it's the multiplication, who knows, maybe it's the division or the creation of a fraction or something. You decide what that outcome will be. The event distinguishes itself from the outcome because the event is something that you are interested in. Okay, for example, what's the sum that between the 2 die when it's going to be less than or equal to 4? I mean, I chose that arbitrarily, but you could have chosen anything. Now, it could happen that your event might only have one outcome in it. So this one actually had 1, 2, 3, 4, 5, 6 outcomes, okay, that were possible, okay, within here. But maybe if we said, sum was less than or equal to 2, well, that only happens once, so that would have been one outcome. Okay, so it depends how many outcomes will be part of an event. So, keep that in mind. And then the sample space is just the entire possible outcomes that you have. All right, so that's the first component and the first kind of terminology that you run into. Now, the second component, okay, within this particular video is that, you know, when you're talking about probabilities, right? So these are just outcomes and then events. If we are starting to ask ourselves the question, you know, what is the probability of an event? So in this case, let's say, what's the probability of the event that the sum is less than or equal to 4? We can calculate that. You know, we designate it in this particular form. So the probability of the event A. You can create, you know, also, you know, the probability of the complement of A, or A prime, which would have been its opposite. So we can find this out, especially if we have a nice, beautiful table like this. It's not always this easy, but in this case, it actually is. You know, we can write this whole thing out and then count things up. So if you do this, you will notice, okay, there are a few things that to know. If you want to calculate the probability of an event A, then when all the outcomes are equally likely, so we don't have, you know, a die which is like a cheated die, which is going to roll a 1 all the time or something like that. When they're equally likely, then we define these things in the following way. We say that we want to know, okay, how many outcomes, okay, so n stands for the number of possible outcomes that you have of that event A happening, and it will be divided by the total number, okay, possible outcomes in the sample space. And if you do this, you're going to get a number which is going to be between 0 and 1. And you can write it as a decimal, a fraction, or a percent. So you have to be very savvy in converting between decimals, fractions, and percent. So this is typically something done in elementary school, but you know, if you forgot it, put up a link up above there if you want to know how to convert between these. So for this example, right, so if I would take this, so I would be able to actually count. So the number of times, okay, that event can occur within here, that would be, okay, so within here, so that would have been once, twice, 3, 4, 5, 6 times. And the sample space, okay, so how many possible outcomes in total are there? Well, there's, if you count these up, or just 6 times 6, it's going to be 36. So this is, okay, equal to 6 over 36. So this is a fraction. We can reduce this to 1 over 6. Okay, and that would have been our probability. And as you can see, it does fall between 0 and 1. So it can't be negative. It can't be more than 1. You can write it as a decimal if you like, right? So 1 over 6, although it might give you a repeating. So sometimes fraction is kind of the most ideal, which is the one that I like in terms of writing out probabilities. But you can also change it to a percent, you know, so how likely is it, you know, so you can take out your calculator. So you can take out your calculator within here, you know, and let's say 1 divided by 6 will be the repeating. And then you can take your answer and then easily multiply it by 100 and say, well, it's, you know, approximately 16.7 or around 17% that we would draw, okay, and then we would throw 2 die, okay, and then we would be able to see a sum which is less than or equal to 4. So those are the probability of events, okay, that you will have. Now, the complement, so the probability of the complement of the event is going to be always, well, it's 100% minus the probability, okay, of the event actually happening. And the reason for that is because you have that the probability of an event plus its complement, okay, is always going to be equal to 1. And that shouldn't surprise you, right? So if you look at this, well, the complement would have been all the other possibilities. So we have 30 of those, right? So in 30 plus the 6 is 36, and 36 divided by the sample space, or how many we have, okay, would be 36 over 36, and it's 1. So that would have been your complement, okay, which you can also utilize. You'll see examples that I'll do in future videos where I do use the complement a bit because Okay, it's sometimes convenient to do this. All right, so that's another thing, okay, that you should keep in mind when you're studying, okay, and you're just introducing yourselves to probability. The last item that we will have, okay, is this 3 basic types of probabilities. And I'll actually show a few examples in a different video. I'll put up a link up above there, okay, to talk about those. So when you are thinking of probabilities, the one that you typically will do, in high school or whenever you're studying is going to be this. What we have just done, what I've calculated, okay, I've actually used theoretical. I didn't do any experiments, right, for that. So the 3 different basic types of probability. So there's something called an empirical probability, which is purely based on trials and experiments that you do. So you're not, trying to do anything in terms of mathematics per se. What you're doing is you are creating an experiment, you're running an experiment, you're rolling those die, or maybe you're, flipping a coin, whatever it is that you're doing. You're looking at nature and seeing what's happening in nature. And then those become your trials. So that's empirical, and that's an actually experimental probability because it's based on real facts. Now, it's never going to be fully out complete because it's impossible for you to do infinite number of trials, right? Because that means you would be doing that forever. So at some point you would have to stop, and then you would be able to calculate based on your empirical results and your data that you've taken, how likely are things to happen. Theoretical is much easier to do because, let's say if you are rolling, a die, you know exactly what the outcomes are. So you can create, okay, that nice little table for yourself or all the different outcomes, and you can see how likely things are going to happen, but you're not creating an experiment. Right? You can also play cards, maybe poker, right? So if you have a 52 deck card poker set, right, and you're dealing 5 cards, you can theoretically state, okay, what are the probabilities of, let's say, drawing a full house or maybe a royal flush? I've kind of talked about in terms of counting those poker probabilities. Maybe I'll put up a link up above there for those who are interested. And for yourself, it's a very nice thing in terms of learning how to do combinations, right? As you're kind of going through your studies. So theoretical is things that we haven't done any experiments for. We just simply calculate from all the possible outcomes that we may have. Subjective was just nothing else but an educated guess. And if you get into sciences, your guesses do become a little better, and you can certainly guess certain things. I can take a guess if the sun is going to rise tomorrow. Well, based on my experiences, it might be a cloudy day, so we might not see the sunrise, but it certainly is rising, right? Or because of the fact that our Earth is continuously rotating. So, I would say that's 100%, okay, that I would take, but it's still an educated guess. It doesn't mean that it will happen forever. Maybe at some point it won't. Hopefully it's going to be staying with us. So subjective probabilities also kind of play a role. Anyone who wants to gamble away, on certain things in terms of, let's say maybe sports teams playing. Or an athlete, in track and field, are they going to win a race? What the probability of that is. And, all those gambling parlors are trying to figure that out. But it is very subjective in a sense because of the fact that, within humans, we can't take all the different things, okay, into account to calculate a theoretical, okay, probability. You can calculate a theoretical probability, of maybe playing blackjack, okay, or poker, as I mentioned, or, if you have a roulette, okay, because you can see all the possibilities, so you can do that and then take your shot at that. But you can't necessarily do that with, for example, sports teams, okay, because there's a lot of subjective items, okay, that are into play. So you're going to run into this empirical and theoretical and subjective, but okay, pretty much everything that you do as a student typically will range in this theoretical result. All right, so I'm going to stop here for introduction, at least the first introduction to probability. Okay, and I hope that this has given you, okay, a nice intro, okay, to some of these probability terms, okay, that you've seen. So outcomes, events, sample spaces, knowing probabilities come between 0 and 1, and I mentioned the complement of an event, and then the 3 basic probabilities. All right, we'll see you in a future video. Bye, everybody.